Welcome to Ask and Learn.
Okay, I've seen this problem many times, or variants of it. So you have a sheet with positive charges on it, and then you have a charge suspended on a string somehow. I guess this is a good model for like pith balls, which I've seen in lab. Okay, anyway, and then you know that this angle is 30 degrees, and then the goal is to get the charge density on the plates equals question mark. I'll go ahead and start it by writing out what's given. So the mass is, so it's 1 milligram, and so I need to convert that to kilograms, and so that's 1 times 10 to the minus 6. And the charge is, I think it's 2 10 to the minus 8. Let me double check. 2.0 times 10 to the minus 6. Okay, that's also 1.0. I'm not going to write it. Okay, great. So to do this, you want to just do a free body diagram on the ball. So you have the weight down, which I'm going to denote force of gravity. You have the tension force. So I'll call that F sub T. And then you have the repulsive electric force. I'm just going to double check the signs of all these. Yes. Positive sheet and positive charge. And then the charge isn't moving, and so you know that the total force is 0. So then, yeah, you can say that the forces in either direction balance each other. So I'm going to label this angle as 60 degrees if this one's 30, because you can make a 30, 60, 90 triangle. So in the x direction, that means that the force from the electric field has to be balanced by the horizontal component of the tension force. So that's Ft cos 60. And then for y, you know that the vertical tension force has to be balanced by gravity. So you can say Fg equals Ft times the sine of 60. And basically you have, the two things you don't have are the electric force and the tension, but you can do some algebra to get the eliminate tension, because the problem doesn't ask about tension, though it is an unknown. And if you do that substitution, then hopefully you get what I got, which is Fg over tan 60 equals Fe, and then again, that uses trig, so sine 60 over cos 60 is tan 60. So now it's time to plug in the gravitational force and the electric force in terms of the things that were given. So I'll go ahead and do that. And Fg is mg, so that's mg over tan 60 equals sigma over 2 epsilon naught. So that's the electric force, and then, or excuse me, the electric field, and then force is charge times field, and so you get that. And so algebraically isolating sigma, I'll do that on the next page, although it's probably not necessary. It feels more complete though if I do. So it's 2 epsilon naught mg. Like, I feel like if I'm cutting out all the trig and you need help with that, then it's probably, like, I don't know, this is a bit more basic than all the trig, but yeah, it feels a lot more complete to write this out this way. And so if I plug in everything, so G is 9.8. If hopefully you didn't forget that. Somehow that's a memorable number, I think. So when I plugged that into my calculator, I got 5. Oh, that looks like a 6. 5.0 there's like a lag here. 5.0 times 10 to the minus 9 Newton per Coulomb meter squared. I'm just going to double check the calculation. Okay, great. It looks good to me.